Okay. Okay, hello everyone. I hope you're doing well on this fine evening. Tonight we have a Unity deep dive by Fouad Abou Harfouch. He is a Unity developer, and he was one of the winners of last year's Gaming Academy. And today he's giving us some of the secrets of developing a good game through Unity. So Fouad, the stage is yours. Enjoy.
Thank you. So hi, as Ashraf said, today will be the first of a couple of Unity deep dive sessions where I'll be showing you how to create a game from scratch in Unity, a very basic sort of 2D game. And now I'll show you a little bit later what we'll be creating. First of all, a little bit about myself. First of all, can you guys see the slides? Okay, great. Like Ashraf said, I was a participant in the first edition of the Gaming Academy, and this is the game that I am currently working on. It's called What Remains of Ish. It's a 2D Metroidvania, but enough about that. So last time, you guys should have, during multi-summit session, should have gotten familiar with the Unity interface, how to move around in Unity, placing objects and whatnot, importing packages, and how to create a project. Today we'll be going over how to create gameplay elements in Unity. So I'm going to be going into the nitty-gritty of all the Unity-specific elements and how you can use them to create gameplay elements. Very quickly, I want to ask you guys what your experience with Unity is. Have you used it before? How new are you to it? Nope. Okay. Was yesterday. I only made a flat. Okay. So this will be very basic. You don't need to have any experience with Unity basically or even programming in general. I'll be going over literally everything. So let me show you guys what we'll be creating by the end of not the session, but the second deep dive session. Hopefully you can see my Unity. This is a small little prototype that I built of a top-down sort of roguelike game. As you can see, we have our little character, a small level. We're just gonna give this a second while it loads. So yes, as you can see, we can walk around, we can hit stuff, we can also take damage. There's some nice little screen shake. You can see some particle effects once we walk, and a little audio cue for footsteps. And if we die, you can see also we have some UI. There's also like a menu, start menu. So these are all there's also some healing items that we can pick up here. So hopefully by the end of these 2 sessions, you guys will learn how to create, or will have created something similar to this. So let's get into it. First of all, I'm gonna close this. Is the screen lagging? Yeah, well, unfortunately, sharing stuff over Zoom is a bit hard, especially with Unity, so it will lag. I will try to go a bit slowly as I'm explaining stuff. Yes, it does have some difficulties sharing games. So first of all, we're going to create a new project. We're going to open Unity Hub, click New Project. We're going to select 2D Core, and let's name it GA top-down game. Matter, and let's create the project. Just going to give it a little bit of some time as it opens. So the assets that you guys saw in that little demo are from two sources. The sound effect is made by Kenny, which is an asset maker that does a lot of free assets that you can use in your projects. And the main things that I've used is this assets pack that I found on itch called the Dungeon Tile Sets. I'm actually going to share with you guys a zip folder that you can download to use if you would like to follow along with creating this game. You also will need it if you want to do the assignments. So here it is. Let's see. Did Unity open? Nope, it still needs a little bit of. Well, here's the first Unity lesson. Patience is a big thing that you will learn using any game engine, really. Yeah. So grab some coffee, grab some tea, grab whatever drink you want, and bear with me as Unity does its thing. What's in this? I'll go over some of the concepts. So really, there's three main components to any Unity project. You have scenes, which is basically where all the content that you create lives. All your characters, your lights, your audio, everything lives inside of scenes. And your Unity project, depending on how complex it is, can be anything from a simple, one scene game that just goes from different level to level to something as complex as having multiple scenes loaded in at once. Here's, for example, what a default Unity scene would look like with a camera, directional lights. I'll go into this a bit more later when Unity opens. Let's see, actually. Okay, it's actually taking some time. Not sure why. The second big concept that you need to be familiar with is game objects. So game objects are basically the most basic building block for a Unity in Unity. Everything and anything in Unity is a game object. Your camera is a game object. Your light is a game object. Your VFX are game objects. A game object is basically a container for, on their own, they don't do anything. They are containers, and they need what we call components to implement the functionality of whatever it is you need that game object to do. Oh, there we go. Unity has opened. Let's see. Can you guys see the Unity? Okay. There we go. You should be able to see it. There it is. Now, yes. Okay, great. So you see here, once we launch Unity, we have this very basic sample scene with only a main camera and nothing else. And we can move around. Let's start by creating a simple game object, just an empty. We'll hit right click and click create empty. And it created this empty, it's nothing. It's just a empty game object with a transform component. A transform component will automatically be created with any game object. It is what defines the position, rotation, and scale of your object. So to start, actually, I'm going to delete this and actually create a square. You see here, the square has a transform component and a sprite renderer. The sprite renderer component is what allows the sprite to be rendered on screen, as the name says. So, okay, simple, very basic so far. Let's say we want to add some physics to this object. We're going to hit add component and look for rigid body 2D. And let's see. If we play now, we should see, we'll see. Yeah, as you can see, the square just falls. It's affected by gravity. And this is basically what the rigid body 2D component allows us to do. It allows the game object to enter the physics simulation of Unity. You have multiple, if you look here under body type, you have multiple different types of rigid bodies. A dynamic rigid body is basically automatically affected by gravity. It has a mass, and it will collide with other objects. So if we, for example, let's create another sprite here, a square. I'm going to hit R to scale it. And actually, I'm going to add a collider a box collider to this object. The collider component will just will define, it's a bit hard to see here, but you can see these green lines. This is the collider shape. And it will basically allow objects to collide with this object. So now if we hit play, it goes through our object. Now, why is that? That's because we didn't add a collider to this little square here. So we're just going to do that really quickly. Add a collider, and now it should collide with it and stop. There you go. And you can see here, you can throw this around, it will collide with it. So this was just a quick overview of the very basic components with Unity and how to get physics working in Unity. Any questions so far? Okay, good. So how do we start to create something like what I had demoed at the beginning? First of all, let's start by importing those assets. So I'm gonna grab this folder and drag it here. So as you can see here, I've added this folder, which has a bunch of sprites, like this chest, for example. So first thing we're going to do, we're going to go to the heroes and just pick this one, this little knights here. And if we click on the square, you can see here in the sprite renderer, this sprite parameter, we're actually going to drag our knight and place it here. And as you can see, he's very, very small, but we have our little knights now being rendered on screen. And I'm actually going to rename this object to player character. Oops. Now, why is he so small? Let's look at this knight's sprites. You can see here in our inspector, we have a bunch of options. So here, type a lot of textures. I'm not going to go into all of them. Sprite 2D and UI is mainly what you're going to be using in your projects. We have the sprite mode. So this defines whether the sprite is a single sprite, or if you have, for example, a sprite sheet, you can set it to multiple, and that way you can actually export. I'll actually show you an example later on. What we want to concern with the main thing we want to focus on here is this pixel per unit parameter. So this defines how many pixels is in one Unity unit. So units are kind of like this little box here. File isn't being exported. Hold on, I'll get to this in a second. So you can see here, why is he so small? Well, basically this sprite is a 16 by 16 pixel character. So what we want to do is we want to actually set this pixel per unit to 16. And if we hit apply, you see he's now much bigger. That is the size that we want him to be at. Let's just adjust the collider so that he fits into it. But you can see he's still a bit blurry. To fix that, we're going to go again on our knight sprite here. We're going to go to filter modes and select point no filter. So what was happening here is our sprite was being pushed through a filtering algorithm to sort of, this is just an optimization of the rendering optimization. Now for pixel art, it looks quite bad. So you always want to have point no filter. But if you have something, for example, like hand-drawn assets that are big, you could get away with having it be bilinear or trilinear. But for now, let's stick with point no filter. I'm actually going to delete this square here. Okay. So we want to create a top-down game. And right now, our character, if we hit play, is affected by gravity. You can see he's going to fall once again, which is not what we want. So here in our rigid body component, we're going to set gravity scale to 0. This means that it will still be a dynamic rigid body, so he'll still collide with other objects, but he will not be affected by gravity. And if we hit play again, as you can see, he's not falling, which is what we want for now. Why give it rigid body again? So a rigid body will allow this object to collide with other objects, and yeah, it will basically it will basically tell Unity this object belongs in the physics simulations. Yeah. Okay. I hope that kind of answered your question. What's the difference between dynamic and kinematic? Good question. So dynamic basically means that it will automatically be affected by all the physics. So if we hit kinematic here, you see we lose all these options like gravity, and angular drag, linear mass, linear drag mass. Kinematic basically means that this object will still detect other colliders, but it will not be automatically affected by physics. It's used for when you want to specifically through code determine your own sort of physics and movement. Whereas dynamic, it's automatically through Unity, it's automatically calculated. And you can see also you have static here. Static just means that no matter what, this body type will never move. What we want is dynamic because we want it to be affected by some collisions. Okay. Let's see. So we have this character now, and we want to move. We want it to move. We want Unity to be able to detect our user input and know how to move this character. So to do this, we're going to hit Add Component, and we're going to create a custom component. Let's call it Player Controller. And yeah, we hit Create an Add, and it's going to add a new component. See here called Player Controller. And if we navigate here to our asset, actually, we're going to see that it created a script file, a .cs file. So we're going to double click this, and it's going to open up Visual Studio. Hold on, let me make sure that it's sharing Visual Studio. No. So hopefully now you guys should be able to see my Visual Studio. Can I get some confirmations? Yes, okay, awesome. So we see here, we just hit here in Unity, we just created a component here, and it automatically created a script that has some pre-written code. So I'm going to walk through this code step by step. You see these using statements first. So what do they mean? This using statements basically means that this script is importing codes from other predefined scripts. Namely here, you have the using Unity engine. This allows it to basically use, for the script to have access to a lot of the Unity functions that will allow us to, for example, read input and, well, a lot of things. It will allow it to use this class here, Monobehaviour. So let me jump actually to my slides very quickly. So Monobehaviour. This is the base class that every Unity script that you create will inherit from. It basically allows you to use it provides the frameworks which allows you to attach a script to a game object. So if we go here and we remove Monobehaviour, and let's go back to Unity. Yeah, you're going to see here we have an error. Player controller is missing the class attributes. And here on our player character, the associated script file cannot be loaded. That's because we removed the Monobehaviour inheritance. So this Monobehaviour allows us to attach scripts to our Unity objects, and it also allows us to use these event functions. So what are event functions? So basically, event functions are functions that Unity will call in its simulation determined order. So you have awake, which is a function that will be called the moment you hit play. You also have start, which is called before the first frame renders. You also have update. Update is called once per frame. This is dependent on the frames per second that your application is running at. So if you have something that's running 60 frames a second, this update method and everything that is inside of it will be called 60 times per second. So let's, just as an example, we're going to write debug, debug.log, and just say starts. And updates. So here, this debug.log will just, what's the difference between awake and start? Are they used for different purposes? Yes. Actually, let me show you. If we write void awake, and let's write debug.log. So before I go any further, this debug.log, what is it? They basically, anything, this is the debug class that is provided by Unity, and whatever we write here will show up in the console window. So here, inside the console, you will see once we press start, we have three things. We have awake, start, and then updates. And this is the order in which they were called. You see, they're awake and start are basically called at the exact same time, but awake is called before start. It is always called, it is basically awake. Sammy, you were asking what the difference is. Awake is the first function to be called. Start is called later on. And as you can see here, updates is being called many times, and you should probably never have a debug log inside an updates because it will clog up your console. So we're just going to remove these. Okay. Unenable works before or after starts. I think it's actually called. Actually, this is a good time to look at this. I'll be sharing these slides with you guys, by the way. And here, I left a link to this very helpful page in the Unity documents, which basically shows you this is a graph of all the event functions and when they are called. So as you can see here, first you have awake, then onEnable is called, then you have reset, and then start. And when do we use update fixed, or I think you mean fixed updates? So as I was said before, updates depends on the frame rate that your Unity application is running at. So if it's running at 60 frames or 30 frames, whatever is in the update method will be called dependent on that. Fixed update, however, is called, as the name suggests, at a fixed rate. So you would want to use fixed updates for things like physics calculations, because let's say you're moving your character, you don't want that movement calculation to be dependent on how the frame rate of the application. So let's say you're playing a game and the game lags. I want to move the same amount that I would have moved, and not like, you know, not have it be dependent on the frame rate. Okay. Okay. Before we get into this, so we want to get this player character to move, you know, up, down, left, and right, and diagonal. So we need some way to read user input. So let's do this. First of all, we're going to create a vector2 called movement input. And we're going to, in our update, call movement input.x equals inputs dot get access raw, and don't worry, I'll be explaining everything here. Horizontal. Okay. Horizontal. So we did a couple of things here. We wrote down this variable here, which is a vector2. So these variables, there's a lot of different variables that you can use in your projects. There's floats, which are, let's say, move speeds equal to 5. So floats are decimals. Think of these variables as kind of data containers, and these data types determine what type of data this container can hold. So floats allows us to hold decimal numbers, whereas integers allows us to hold just let's say and just gonna call it integer. So we can't have, for example, something like this will actually throw an error. Integers can only be whole numbers. You also have Booleans. So Booleans are can be either false or true, and we use them for conditional statements, and you'll see how we're going to be using them. It will become more clear once we get into examples. So what is a vector2? A vector2 is basically it holds an x and a y. It holds two values, and we use it to, here in this example, we're going to use it to read the x user input and the y user input to determine how much how we want to move our character along the x and the y axis. So input dot get access raw vertical. So This input.getAccess raw. What is it? So this is the Unity input class. And we're just going to go back to Unity for a second. And if we hit window here and go to, where is it? Actually, I think it's in the, yes, there you go. If you go edit, project settings, and in the project settings, you can go to input manager. This input manager defines some predefined inputs that you can use in your game. So you see here you have horizontal and vertical, which are you have different, hold on, sorry. Let me actually go to my slides so that I'm also not confused. Okay. So you see the input manager has different types of controls. You have keys, which just refer to different keys on your keyboards. You have buttons that can be mapped to a physical controller. And you have a vertical axis, which is, it can be mapped, it's as like a button or key, it can be mapped, it can go from a range of -1 to 1, and you can basically use this to mainly for movement inputs. Can we learn the new input system for this project? Unfortunately, I think it's a bit out of scope for this one. If you want, I can like help you out if you want to learn how to use the new user input system, or I can link you to some tutorials that go over the new input system. But for now, this will do for our purposes. So as you can see here in the input manager, we have a bunch of different predefined inputs like fire, jump. So jump is, you see here we have the name, the positive button, which is the button that you hit, which we'll call it, which here it's the space button. And you have a bunch of different ones. You can also see here you have a separate jump one, and this is mapped to joystick button 3. And this is basically will be called if you are using a gamepad, a controller, what have you. So here in our updates, we see we are getting, we are reading the horizontal and vertical inputs, and we're storing them in our movement input.x and .y. So I'm gonna write a quick debug.log just so you guys can see what is happening here. Yeah. So this is movement horizontal. And I'm just going to copy this one vertical. Okay. So if we go back to our Unity now, let's close this, hit play. So as you can see, they're being called, the rdebug log is being called, and it's right now I'm not hitting anything on my keyboard. So our horizontal movement and our vertical movement are 0. If I hit the right arrow, think I need to, there you go. If I hit the right arrow, our movement horizontal is now displaying 1. If I hit the left arrow, it's -1, and up arrow or vertical is equal to 1, and down arrow or vertical is equal to -1. So I think you get the idea. Depending on what arrow button we're clicking, this movement input will reflect that. Okay. So now we're reading the arrow inputs. How do we actually move our character? So in order to move our character, we first thing first, we want to be able to access the rigid body component that we've added to our character. So we're going to write rigid body 2D, rigid body components, and here in our start, we're going to write rigid body 2D equals, and you can see here IntelliSense already knows what we want, so I'm just going to hit tab. So rigid body component equals get component rigid body 2D. So this can get components is a very, very important function which allows us to which will do, what we'll do is check what components we have on this game object and returns the first component of type rigid body 2D. So now that we have that, we can actually access our rigid body components. And by the way, there is a different way we could have done this, and let me show you really quickly. Public rigid body 2D components. So here, actually, so here we have two rigid body parameters. One is private and one is public. So what's the difference? These are what we call, I believe they're called access modifiers. And basically, a public variable or public field will be exposed to all your other Unity scripts. So if, for example, we wanted to read this rigid body component from a different script, we need it to be public. And if it's private, then it lives within the scope of this script, and it can be accessed outside of it. Another thing that this public modifier does is, if we go here, you can see in our player controller script, we now have a rigid body parameter that we can click on our rigid body 2D component and drag it here, and basically assign this component to this rigid body 2D component field. Let's keep it this way. So as you can see, this basically does the same thing, except here we can assign it through the inspector, and with the private modifier, we need to actually call get components to be able to access it. So I'm going to keep the public one. And let's take this rigid body 2D components, and we're going to set dots. And you see here, when I hit dots, we have a lot of options here. And these are all the functions and different properties that we can access of the rigid body 2D class that we can access. Like you see, you have add force, add torque. We can check what the body type is. we can see what the game objects that this rigid body 2D is connected to. So what we want is we want to move our player. So we're going to write move position. And this move position is basically going to, if we hover over it, we can see that it says moves the rigid body to position. So we want to give it the position that we want to move this rigid body to. So how do we do that? We're going to get the current position by doing rigid body to the component dot position. So this returns the current position. And we're going to add to it the movement input times a movement speed, which is right now a variable that we have not defined, which is, as you can see, it's going to throw an error, times time dot fixed delta time. So don't be scared. Again, I'm going to explain what all these things do. First of all, this movement speeds, we need to actually define it somewhere. So we're going to say public float, since we want this to be a decimal number, move speed. And we're going to say that by default, it's equal to 5. If we go back to Unity, you can see here, we have this decimal number that we can control. And actually now, if we hit play, we can now move our character. So I'm hitting, AD, I'm using the WASD to move around this character. So so here, just to explain this a bit more, we're creating the current position, adding to it the movement inputs times the speed times time dot fixed delta time. So this is, if we read here, the interval in seconds at which physics and other fixed frame updates. So fixed frame updates are performed. So delta time is basically the time between every Unity frame. Fixed delta time is it will make, what we're doing here is basically making sure that our movement is actually frame independent. And if we hover here, it will say that update should use time.delta time, which is why we don't actually want this to be called here. We want to actually call this in fixed updates. That way, as I've explained before, if the game lags for whatever reason, the rate at which we're moving our character will still be stable. Okay, I hope everything makes sense so far. Okay, so let's see. So now we have this character. We can move them up, down, left, and right. Let's see. One thing that's bothering me here is that if I move, right, he's always facing in the same direction. So I want him to flip towards the direction that I'm moving him in. So let's do that. So how do we do that? We're going to create an if statement. So an if statement is a conditional statement that will basically will have a condition, will read a condition, and depending on whether this condition is true or false, will run some code. So here we want to actually see if our movement input.x, so our movement on the horizontal, is bigger than 0, then we want to flip, we want the character to face right. So how do we do this? We're actually going to call the transform scale. So before I do this, I'm going to show you how to do it by the editor so that it's clear what's happening. So if we see here our transform components, if we take our x and we set it to -1 instead of 1, as you can see, our knight has flipped to be facing left. And if we set it to 1, it will be facing right. You can also do it by clicking this flip checkbox in the Sprite Renderer. But for us, we want to actually do it through the scale, and you'll see later on why we did it this way. Okay. So here we're checking if movement inputs.x is bigger than 0. We want to set the transform.local scale to be equal to new vector 3 1 1 1. So this will set our scale to be equal to 1 1 1 on the x, the y, and the z's. And here, if the x is smaller than 0, we're going to say transform dot local scale dot x. Actually, just transform dot local scale equals new vector 3 minus 1, 1 on the y, 1 on the z. So let's see here. Hit play. So yes, if I move to the left, he's facing left. And if I move to the right, he's facing right. Although now you might actually spot a small bug here is that whenever I actually am moving left and I let go, he will default to facing, when I move right and I let it go, he will default to facing left all the time, which is not what I wanted to do. I wanted to face the last direction that we were moving in. Can't we use vector 2 here? So let's see, if we try to use my vector 2 here, let's say transform dot local scale equals new vector 2 1 1. You can it will automatically see, as if you scroll over here, actually the local scale is a vector 3, but if you can always use a vector 2 instead, it will automatically convert it to a vector 3. Okay, so we want this we want the knight to always be facing the last direction that we were moving in. And actually, to do this, we're going to, instead of saying else, so what's it doing here is it's checking if the movement.x is bigger than 0 and setting the knight to be facing towards the right. Okay, hold on, I'll get to your question. And if it's not, so if it's smaller than smaller or equal to 0, it is setting it to be facing towards the left. So what we want to do here is actually say else if movement input dot x is smaller than 0, flip this character. And now we'll see if we hit play. Now, if I move him to the right and I let go, he's still facing the correct direction. If I move him to the left, he's still facing the correct direction. So great. We have our little knight, and we're almost done with the movements. So this update file function it's gotten a bit busy, not too much, but we generally want to keep it simple and clean and readable. So what I'm going to do here is I'm going to jump a couple of lines and write voids, flip, open parentheses, and then open the curly braces. And I'm just going to copy this code and put it here. So what we just did here is we created a function or a method. And we have a couple of things. This void, what does it mean? This is the return value of this function. So void basically means that this function will just be called, and it will run through its lines, and that's it. It won't return anything. If we change it to, for example, bool, you see here we have an error. Visual Studio is telling us that we have an error. Not all code path return a value. So this is now expecting us to return some sort of value. So when this function is called, it will either return true or false. And you can see here we can actually write return true. It will always return true. Now we don't want this. We just want it to be void. So we have void, and then we have the function name. We have these parentheses, which inside of these parentheses, we can add parameters that we can use in our function. I'll get back to this later, maybe. So this flip, what we want to do is what we can do now is just remove this code that we've written here and say flip. This will call the flip function, and it's basically doing the same thing. This is just for readability. So that we know, okay, we're getting this movement input, and then we're flipping, and we can actually move this this piece of code here into its own method. You can see also, if we select it, we can click extract method here, and it will create a method for us. Let's just name it movement inputs. And there you go. Now, at a glance, we can tell, okay, in the update, we're doing the movement inputs, and then we're flipping. Okay. So if we go here now, and I'm actually going to hit play, and I'm going to show you a little bug that we have in our codes. So as you can see, if we move right, up, down, we're moving at a certain speed. But if I start moving diagonally, you can kind of see that we're moving a bit faster than our left our horizontal and our vertical speeds. So why is that? Well, what's happening here is that the magnitude of our vector, so the vector, the movement input vector, actually, I should talk a little bit about what vectors are. Vectors are basically a direction and a magnitude. So a direction is where this vector is pointing. And actually, I'll go here to my slides and show you. Let me show you vectors. So yes, we use them to describe a direction and a magnitude. A magnitude is basically the length of a vector. And vectors are used everywhere in game development to determine the positions and movements and distances between objects. So what's happening here? Why is it that when we move on the diagonal, our character is moving faster? It's because the distance, the magnitude is actually bigger, is actually greater than 1 on the diagonal, because we're adding both our horizontal and our vertical movements. So to fix this, it's actually quite simple. We're just going to say here, before we calculate our movement position, we're just going to take our movement input and call dot normalize. So if we scroll over this normalize, we can see here, makes this vector have a magnitude of 1. So this will just make sure that our input vector is always has a magnitude of 1, no matter what, no matter what combinations of inputs we're given. If we go here now, you can see we've fixed this. So we're moving at a constant rate. I know this was probably a bit of a confusing section, so tell me if you have any questions and I will answer them. Okay. About normalize, yes. Actually, I think it's been an hour that we've been in this session. So how about take a small 10-minute break? I'll be here to take any of your questions and answer any of your questions. So whoever, go take a break, get some coffee. Probably don't get some coffee. It's kind of late. Get some water, stay healthy. So, and we'll come back here in like 10 minutes. And after the break, I'll be covering adding a tile map and actually creating a small level.
All right, wonderful. Thank you. طيب, and we'll see you in a few minutes. Yalla. All right, welcome back. We're here to continue. Fouad. So yeah, enjoy.
Okay. So little recap of what we did so far. We have our character. If we go back to Unity, we have our little knight character. and we've created the player controller script that moves him around and flips him depending on the direction of the movement. So very simple stuff so far. Now this is very boring. You know, we're just moving in a blue space. This could be a game, I guess, but not a very visually interesting one. So we're going to add what's called a tile map to start creating a level. So we're going to go to our project window here, click on the assets, go sprites, tile sets, and we have this tile set here that has a bunch of different sprites. And this is what we're going to use to start creating our levels. First of all, with all of the sprites in this project, they're all designed to be 16 by 16 pixel sprites. So we're going to set the pixel by units to 16. There we go. Oops. And since this has multiple sprites, we're going to set the sprite mode to multiple and the filter mode to point and hit apply. Then we're going to open up our sprite editor. So here we can start to, we have our tile sets here, and we can slice, we're going to tell Unity how we want it to basically read this file and how it's going to separate the different sprites. So we're going to say grid by cell size. We clicked on slice, grid by cell size. And since we know that these are 16 by 16 sprites, we're going to say pixel size is 16 by 16. Hit slice. And as you can see here, it has created a bunch of different little subsections of our sprites. We hit apply. And close this. And here, if we hit this little arrow, it will actually open up. And you can see that from this one tile set, we have a bunch of different sprites. So we're going to use this to create our tile map. So what is a tile map? So a tile map is a system that allows you to create 2D levels using tiles. So in this Google Slides, I've actually put a couple of slides that explain how to create a tile map in case you guys want to follow it later. So here, let's see, create a rectangle tile map by object tile map. So I'm going to do this. Let's go back to Unity. And we're going to right click and go to 2D object, tile map, and select rectangular. And this is going to create two game objects. Our grids, if we go here to scene, actually, you see now we have a grid and a tile map. So this will allow us to basically render tiles on this grid. So how do we do this? First, we're going to want to go to Window and 2D and open up the tile palette window. Click this, it will open this window here. I'm going to Docket Chapter. And you see here we have a bunch of options, and here it says create a new palette in the drop down above. So we're going to do exactly that. We're going to name it, let's name this palette grounds. Actually, I'm going to name it dungeon palette. It creates, and this is going to open a little window. It's going to ask us where we want to create this palette. I'm going to put it in the tilesets folder. So select folder. And now if we look here, we have, it has created this object, which is a palette, a tilemap palette. So now that we have this, it's going to say here, it's going to ask us to drag tile, sprite, or sprite texture assets here. So what we're going to do is this sprites, this set that we've created, we're going to drag and drop it here. Actually, before doing this, we're going to create a new folder and call it tile assets. So I'm going to drag this here, and again, it wants to generate tiles into folder. So we're going to generate these tiles into our tile asset folder. It's going to do some importing. And basically here, what we're doing is these different sections that we've sliced from our big sprite into little, multiple sprites, into little 16 by 16 sprites. We're basically adding them to our tile palette. And what it's doing now is it's creating these individual tiles so that Unity is able to reference them so that we can start painting them on our tile map. Okay, now it's done. We can see here it's in our tile palettes, we have a bunch of things. And let's look at these controls first of all. So select an area on the grid. This allows us to select on an area on this grid game object. So let's see. We also have the most important controls that we have here is our brush. So if we select a tile here and then select the brush, we can see here that now we can kind of come here, and by just clicking, we can paint these walls here. And I'm just going to Control Z because this is not really what we want to do. So let's select this ground, and right now we can already start to create our level. We can place a ground, and let's say I want to place multiples. So I'm going to select this box brush, and we can just click and drag, and it will create a ground for us, as you can see here in the game scene, in the game view. And let's just, give ourselves a little bit of space. So this is basically how you can start creating your levels. You can select different tiles and start adding, some breaks in the ground. Select the brush here. You can even select multiple tiles, and with the brush tool, come and just place them around. And let's select this wall, for example. And you see here, there's a bit of a problem. If we place this wall, it's kind of, it's replacing the ground under it. which is not what we want at all, right? We want these walls to be kind of rendered on top of the ground. So how do we do that? Well, first things first, I don't really care about all of these here. I just want this palette to be able to create the environments, and I don't really care about the characters or the different weapons. So I'm just going to hit edit, and this will allow us to edit our tile palette. And I'm going to click this erase tool, and we can just erase what we don't need. And a little shortcut is you can actually select this box too, and if you hold shift and drag, it will erase whatever is under it. So just to keep things simple, this is the palette that we want to be playing around with. Let's hit edit so that we exit edit modes. And also, by the way, you can select the erase tool and erase stuff in the actual tile that we placed. So how do we make it so we can place walls and they are rendered on top of our ground? Well, we want to actually create a new tile map. And as you can see, it's automatically gets created under this grid. So they're all both these tile maps are part of the same grid. And I'm going to name this one wall and rename this first one to ground. So all our ground tiles are going to go on this ground map, and all our walls are going to go on this wall tile map. So now if we select these walls, there you go. It's no longer replacing the ground because it's actually being rendered on a separate tile map. If you go here on the tilemap object, you can see there's a tilemap renderer, which is similar to our sprite renderer. Here, it's just for specifically rendering tile maps. And we have one for the ground and one for the wall. So let me actually talk about thing here, sorting layers and order in layers. So what is this actually? So we want our walls to be always rendered on top of the ground. So how do we make sure that it's how do we make sure of that? So basically, this is where sorting layers come in. Sorting layers are determine basically any object that is rendered on screen is a part of a sorting layer. So as you can see here, both this tilemap renderer and this one and our player are all being rendered on the default layer at the same order. So if I were to take the player character and put -1 here, he disappears because now he's being actually rendered. And look, he's kind of like peeking a little bit here. He's actually being rendered behind our ground. Now we actually want him to be rendered on top. So we're going to say something like 1. And for our walls, similarly, I'm going to set the order and layer to be 1. Okay, now that's done. Let's go ahead and place some walls. So just going to place a couple of walls here, and to grab this section here. Actually, we need this corner segments. There you go. And I'm just going to create a little box. We can select this one here and this. if you could fast forward in real time, this was what I would be doing right now. So there you go. We've created our little box here. So let's hit play and see what happens. Actually, I'm going to select our camera. It's a bit zoomed in right now. I'm actually going to, I didn't touch on this. So if you select our camera, you see here, we have a size. And if we increase this, it will actually increase the zoom or decrease it. So I'm going to set it to something like 8. This feels a bit nice. And you can see here, we can also change this background color. So I'm going to make it dark. And just to keep things a bit nice, I'm going to select our grounds here. And I'm going to erase these little extruding things, just so we have this little box here. So now, you've seen how to kind of create a little, very basic map. You can expand this to create, very large maps with this. But as you can see here, we're moving around. The walls aren't really doing anything. They're just there. They're basically just decoration at this point. And obviously, this isn't what we want to happen. We want the player to collide and stop once they hit a wall. So how do we do this? Well, we're going to want to add a collider to our tilemap. So selecting the wall tilemap, we're going to click Add Components, and we're going to say tilemap collider 2D. And just by adding it, you see it's for each individual tile on this tilemap, it has created a little collider, which is great. This is what we want. We're going to also give it, actually, before doing that, I'm going to hit play. And now if we move around, you can see where the player now collides, and he's actually doing a little dance, and he's kind of shaking as I'm hitting these walls. And you see if I hit these corners, whoa. So what's going on here? He's spinning around. Again, this could be a type of game that you can make, but maybe not necessarily the game you want to make. So why is this happening? And how can we stop it? Let's go to our player character and let's look at our rigid body 2D. If we see here, basically what's happening is this collider was hitting this corner, and it was basically rotating it to hit the slope. So we don't want, we don't want this player character to rotate at all. We just want him to stay to be straight the entire time. So what we're going to do is we're going to open up this constraints drop down here, and we're going to hit freeze rotation along the Z's. So this will make it so that we can no longer rotate it along the Z's. Click play. And we move. Let's go to this corner. Yep. Everything seems to be fine now. He's no longer rotating. So nice. We have a little player character. We have a very basic map, but it's something. It's a start. We can come here and we can start adding more things. So let's just make sure I have the wall selected here, and I can add these columns. You know, I can come here and add some details. And you can just have as much fun with this and create as big of a level as you can or want to. Okay. So one thing that we still want to change, it's a bit strange to me that he's kind of like his head is colliding with the bottom of the wall. We don't really want this to happen. It's not, you know, it doesn't look quite right. So what we're going to do, and I'm going to demonstrate another thing here. Let's go to the scene view. We're still in play mode. We're going to zoom in and let's open up our box collider. And we're just going to make this a bit smaller. And this collider will just be at his feet. And if we go back to the game view, now this looks a bit better, right? He's moving kind of along the upper wall. But you'll see here that once we hit play again, if we look back, our collider resets. That's because anything you do in play modes stays in play modes. You always need to make sure to, if you do any changes in play mode, that's you need to basically redo them once you get out. And one thing that you could do is you can hit right-click on a component and click copy, and then you can paste those values again. So there we have it. It's getting a bit late. We're almost at the 2-hour mark. So, but not bad. We have created our basic character controller and a very, very basic level. So that's it for this time. Next session, we're actually going to be covering a lot of things. We're going to be creating a lot of different gameplay elements. We're going to be giving this knight a weapon that he can use to attack. We're going to be adding animations. We're going to be adding a very basic enemy and some UI. And hopefully I'll be able to cover that all. Like dances, potentially. You know, no promises. So that's about it. Is there any questions?
All right, cool, wonderful. I think we're good to go. Thank you so much, Fouad, for this session on basically developing our first game. It looks really, really cool, Salaha. I love the pack. I love the movement. I'm super excited for the next session as well. Thank you, everybody, for attending. Thank you, everybody who's going to watch the YouTube session as well. We can't wait for you to create your own game and share like a level or two with us as well. All right. Well, thank you again, Fouad.
Here, by the way, guys, I just sent you the link to the slides, and I'll share them on the Discord as well. So thank you. Hope you had fun.
Yalla, we'll see you guys soon. Take care.
Bye-bye.